Hey, so I'm super happy to share this tutorial with you guys because we will be building something that previously was just not possible, and we will be tapping into some hidden features of BabylonJS game engine. We recently introduced some new components to Rete editor which allow you to code TypeScript directly, and then you are able to use things that were just hidden from you basically. We never had components that can create particle systems, but now through that TypeScript capability you can do that. And in this tutorial we will be building this exact experience that you see in the video step by step. I will show you what it takes to build this, how to make it, where to get the particles and all the rest. So let's get started. Let's tap into those hidden features and begin building. And so to get started, you will need to visit BitBYBIT.DEV, open our Rete editor by clicking this button. And here you will find the code category with 3 new editors for TypeScript, JavaScript, and JSON. We will be using TypeScript editor, so if you click it, you will get it on your 2D canvas. And here you have a function that is called start with some ID next to it that corresponds to the ID of the component. And it just does a simple thing. It takes inputs and returns inputs as well. And because it doesn't have any inputs connected to the inputs part, it will just return empty thing as well. So if we preview the data, you will see that it just returns null. If we say to the function to return number 5, we can run the code again and you will see the number update. If we want to use a number slider, for example, and then plug it to the inputs, we can then also say to return the inputs. And then if we update the slider, you'll see that the number also changes immediately here. So the code executes, right? We can also just compute something here. Let's not make this component go to waste. Let's update the slider now, and you see that the value updates by doubling what's in the slider. And this is working fine. We can, give inputs a type. So now it's a number, and you cannot really assign it then to something like a string. So if we do that, it will complain, right? And yeah, this is exactly the thing that you would expect from TypeScript. But where are the particles? This is all nice and fun, but where are the particles? So the particles are here in the documentation page of BabylonJS. And you may ask yourself, how come this happens that we use BabylonJS documentation page? Well, actually, because BabylonJS is sitting in the core of BitByBit, you can use the code from BabylonJS almost directly in our editors. So what we will do, we will find an example with emitters that use direction. So we will open this in the playground of BabylonJS. And you may have seen this already if you used BabylonJS. This is just a normal playground where you can inspect the code, play with it, and do all kinds of things with it. So what we will do is we will copy paste some code from here, the code that creates the particle system itself. We will not be interested in this context for now, but what will happen is that if we just paste this code, remove the inputs computation from here, you will see that we have a small error. Let's make it larger. Let's also remove these. That as well. And now if you look into this component, you'll see that the scene is not defined. What BabylonJS does is it creates the scene here, but we will be using BitByBit scene that is already created, so we will need to access it like that. So let's do scene. Let's go to BitByBit, Babylon, scene, get scene. This way the scene will be defined and it will be the correct scene. So now if I hit run, voila, we have some particles, but these look a little bit strange, right? So if you look closer, you'll see this chessboard sort of texture, and that just indicates that the texture is actually missing. And it's missing because the script that you see here, it uses a local path to textures/flare.png. And it does exist in this playground, babylonjs.com, but it doesn't exist in BitByBit. So So what we will do is we will just copy this URL. We will go here and we will paste it. So now if I hit the run button again, you will see that the particle system will update. And this is really nice, but the strange thing happens that the old system is still visible. And that's not really good. So what happens is that we executed this code twice. That means that the particle system was created twice as well. So you need to be careful how you execute the code in these components, because you have to do some cleanup first and you have to be quite smart about it. So in this case, it's quite simple, because we know that we just need to clean all the particle systems in the scene, and we will do it like this. So we will do scene particle systems for each, and for each system we will do system.stop. So we call this method. We'll also do one more thing. So we will see that the particle system disposable on stop. We'll see that it should do that. And now if I hit run, you will see that the particle system that we had before disappeared, and we're left with single particle system here in 3D space. So I will just create a grid mesh now so that we see better where this particle system exists. And this is quite nice because it's just making the context more readable. What I want to do is change the position of this particle system, and it's in here. You see that the emitter is assigned the vector 0, and if we would assign something else, like maybe vector 3, but then we need to instantiate the class and say that it's on 0, 5, 0. We can hit run again, and you'll see that the particle system moved upwards. And this is all nice. We can play with this code as we want, but we would like to actually use our inputs to update that value. So how could we do that? Well, the most simple thing is what we did already, right? We had some number slider, and we could just plug that in to inputs and then use inputs value to control the Y direction. And in this case, we will just go from 0 to 5 to 10, and yeah, just play around with it, right? So this is really now taking an actual input from our number slider and using that in code. But we would actually like to control the full position, so with X, Y, and Z. So that is a bit different sort of thing that we need to pass as input to the function. So we can use vector X, Y, Z and pass it in like that. So in this case, the number is not really a good definition of the type. It's actually an array of 3 numbers. And this way we can say that we will just use the spread operator on inputs. And now if I hit run, you will see that the vector is controlling where this particle system emitter exists. And now I can also change this vector to go into a different location like that. And it just controls all 3 axes. So what else could we do with this system? Well, we could play with colors as well, right? But we currently just use up all the inputs with one single array. So there is no way to pass a color definition to this function. And to do that, we will be using JSON data structures. If you don't know how to use this category, we have some tutorials for you. But we will be basically creating a value on the property, and we will use empty JSON to create the structure that represents position. So for position, we'll be using this old vector. And if you do that, you can then update this type, and we will say that inputs now has a position property, which is the old type of number. But we also will have color1, which will be a string, and color2, which also will be a string. So this will make sense to you in a bit, but now let's preview the data that we have, right? We have JSON data structure with single property called position, and we have 3 numbers here. And if we want to extend this, we will need to use this same set component. We will use original JSON to go in here. We will see that we want to set color1 property, and we will go to this color category to create a color component. And now if I plug it here, you will see that our preview data will show us that we have property color1 here. Another thing that we will do is, of course, create a color2 property and pass this and copy this. And now if I preview that JSON, you'll see that we have now a position, color, and color2 properties here. So now with this, we can go and plug it in. You will see that now it's not really happy about the fact that we use the spread operator on inputs, because in fact we need to use position. And that's correct. This is actually really smart from TypeScript that it indicates these kinds of mistakes. And we updated our data, right, that comes into this function. It's now containing this position property, and we need to then update it here as well. So let's hit run again, and our particle system is back and running. But now we have 2 additional properties that we can use in this code. So let's do that. Let's zoom in to this component, because we will be writing some code. I will be creating 2 constants called color1, and I will use Babylon Color3 from hex string method to read this color. So we have a string that we can use, and we parse it to color3 format, and we do that for color2 as well. Let's just copy this code and let's use color2, and here we will just map it like this. So we will say color1.r, so for red, color1.g for green, and color1.blue for blue. And we will do the same here. Just we will change this to 2, 2, 2. And now our colors should be changeable, right? You can adapt those then. Let's do that. Let's play with these inputs. Let's say that the color is now red, and that color is maybe green, for example. Now we fully control what comes into this code through the inputs. We set up this JSON that is looking quite, maybe difficult to you, but yeah, it's basically just an object that has some properties inside. So far, I hope you understand what is happening, because next thing we'll do is we will create multiple systems on multiple vectors. So we currently have one particle system, right? And we would like to reuse this code to create a second. How could we achieve that? There are a few ways, but what we will do is we will just create additional JSON, and we will plug it in as well to this component here. What I will do is I will take the original JSON, I will create another vector like that, and I will update its position property with this different value. So let's now say that we are -5, 0, and maybe 5, so that's visible. And yes, so if you look in space, in the coordinate space, it's here. And what I will do is I will plug this JSON also into here. And you see that it should have worked, but the previous coordinate disappeared. And that happens because we have this magical line here that removes all the coordinate systems whenever we run this code. And because we provided 2 inputs into this component, the component executed twice. And that's part of how Rete editor works. This is also something that is expected. But how can we solve that? Well, we will be using the index that is passed to this function from the context that executes it. And what we will do is we will say if index is 0, only then remove all the particles, right? We don't need to give them any IDs in this case, because we will be just using particle systems made in this component. So now if I hit run again, you will see that I end up with 2 particle systems and one of them isn't removed. So now that I have 2 particle systems, I can also update those colors to bring the original values more or less, something like that. This looks better. And we can also use differently created points. This is quite limiting, right? If we want to add each time a different value property of a vector to create a different position for these coordinates, that is a little bit overwhelming. And I will show you a smart way how we can do this. So let's create a circle wire, and we will be making it larger. Let's make a radius of 10, and let's divide wire by params to points. So this will create multiple points on that circle. You can see it here. Well, maybe it's better to see it if we have more points. So let's have like 40 or something. You see those red dots on the circle. Those are all the points. And if we preview this data, you will see that we have a list of vectors that all represent those points. So what we want to do is for each of those points to create a JSON. Well, how could we do that? And it's in fact quite easy. I will remove this part here. I will pass the empty JSON as a starting point to the value. Another thing that I will do is I will flatten the output of this component, and I will plug this in here, and voila, you see that now we have a lot of particles here. The component is still not very happy because we provided one input without the position property, so I will just remove it, and now it's happy again. So what happened here might seem a little bit magical to you. Well, it is magical, of course, due to all of those particles that look amazing. But basically the idea is that you create many vectors, and when you flatten them up, so you end up with this data structure that looks like this. You see that they are in the second level of the array. That will execute this component multiple times, and you will end up with multiple JSON objects in the array. So here you see that we created a JSON for this first system, and there are 40 systems now created, all based on these inputs. This makes it possible to do all kinds of interactive things. So we can now say that we want fewer systems, like 10 maybe, and now we end up with 10. This is really nice because you can now interact with your code directly in here in this editor. And we can also make this, larger or smaller like that. So 5. So if you don't really understand this concept of how did we magically created that many JSON objects, you should check out some introduction tutorials to Rete editor where we talk about many-to-many mapping and one-to-one mapping. Those explain well how this happens beneath the water, how components can be executed multiple times to create the outputs as you see here in this case. So this is quite simple. We will just plug a number slider here, and we will be able to then control the radius more easily of this circle, and we will change this one to inform how many subdivisions we want to create on those circles, and we'll go from minimum of 5 to the maximum of 50, for example, in the step of 1, and that way we can control both the radius of a circle like this, and also control how many particle systems are being created. So now we have something that already resembles a little what we had in the YouTube video, right? So we have these number sliders, we can make fewer coordinates, And now we can just hit this multiple times, and you see that with some delay you get really nice looking particle effects that go higher, lower, and yeah, it's just fun to play around with these, right? Interactively, you can adjust everything here now, so the radius, the subdivisions, even the colors. So this is really interesting and pleasing actually. So this is it for this tutorial. In the next part we will be talking how to create camera paths by using control flow algorithms, so that you could, you know, create some nice looking animations. And yeah, let's see each other in the next videos. I hope you enjoyed this one. Cheers.